Thank you very much. So if I have a north pole that is dropping through, is my magnetic flux increasing or decreasing? So let's change that a little bit. I got an area vector here. Let's assume the area vector is pointed downwards. So as the north pole, so as this falls through it, is my magnetic flux increasing or decreasing in the wire? Okay, so the current that's induced is going to try to decrease it. It wants to do the opposite of whatever's happening there. So it'll induce a current one way or the other. And the second part was when it's part way through it or after it's gone through, was part B?
At what point will the magnitude of the induced current be the greatest? Looking for a conceptual answer instead of a mathematical one.
Okay. Let's recognize that after it passes through, well, actually, when the magnet is here, I got a south pole and a north pole. Is my magnetic flux increasing or decreasing as it falls?
Decreasing.
Okay, so I'm gonna have, so if it's decreasing and wants to put a current in it, that's going to try to bolster the magnetic field.
Got it. Thank you.
Yeah.
So the magnetic flux increases as it goes down into the loop and then starts to decrease once it passes it.
Yeah.
Okay. And the current kind of does the opposite, or the induced current.
Yes. Yeah, it will. And just remember that the EMF that produces the induced current, the magnitude, I don't worry about plus or minus, is the change in magnetic flux. With respect to time. So. All right, other questions?
Are we still scheduled to have the multiple choice test this Thursday?
We can do it next Tuesday if you want. I'd do either one. And we can even on Thursday decide to the last moment, let's make it Tuesday.
Isn't the master the 28th due Tuesday though?
According to the syllabus, it says 28 is due, correct, next Tuesday. December 15th.
Yeah. We need to cover some material first before that happens. We can, I have the power to adjust the schedule if I have to.
And what would chapters be multiple choice?
The multiple choice basically covers 18 through 24, 23, 24. Unlike the one with mechanics, which in essence really only covered through Newton's laws, this one covers everything that's required for the course, required by the state. Other questions? All right, so let's talk about AC. because we're gonna be dealing with slopes here and reversing of slopes. If I start out with a cosine curve, that my slope is a negative sine curve, and the slope of that is a negative cosine curve, and the slope of that is a sine curve, and the slope of that is a cosine curve, and basically that's the order. Now, when we're dealing with DC current, there's a positive and negative side to my power supply, as we've talked about, and so I have a setup like this, or for the purists, something like that. But with AC, since it's alternating, there's not always a plus side and a minus side, or it keeps flipping back and forth. And so the symbol for AC, an AC power supply, is basically a sine wave in a circle. So this is an AC circuit that has a resistor in it. Because the power supply is alternating back and forth, and it is oscillating in either a sine wave or a cosine wave, depends on your mood at the time. We'll just pick sine. So the voltage is equal to some amplitude here. So why don't we just say 100 volts times the sine of $400T, technically plus some phase shift, depending upon where you actually start. But we will, I'll just throw a number in here, 0.5. This is my amplitude. This is my angular frequency. And this is my phase shift. Which, again, the phase shift just accounts for when time is 0, what's the value of my potential difference. A couple other notes from notation. Notice this is a lowercase v, this is not an uppercase. Generally, when you're dealing with AC current, the uppercase represents the maximum value, the lowercase represents sort of at a moment in time. Unlike a power supply, DC power supply, where I can put in a 12-volt battery, then my power supply is 12 volts-ish. This one, since it is changing constantly, they do distinguish between the two. Another notation bit is that the delta is not sitting in front of it anymore. It's understood to be there, but it is not written, typically. Now, if I take a multimeter, and I am going to walk down, grab a multimeter, since I don't seem to have one in here, and we'll figure out what our power supply actually produces. Grab two just in case. All right, so typically in one of these, common is generally the black one, and the red one goes into basically the higher potential. Basically, we're setting up, common is going to be the lower potential, and red is the higher potential. Now with AC, it doesn't make a whole lot of difference which one I stick in there. But on the multimeter, I put it on volts because I'm gonna measure voltage. And then right now it says DC in the upper left corner. And I hit select, and it's now on AC. Because AC is floating back and forth, how is this gonna give me a value? Because it's flipping back and forth 60 times a second. So what am I gonna actually get? Can any of you read the number on there? Okay, so you'll have to trust them. And assuming this power outlet works. Let's try the other one. Not supposed to be beeping like that. It's on AC. And what number is it reading?
117.3.
Okay, 117.3. Ideally, 120, but, so I got a 117.3 volts. And the question is, what actually is that number? What does that mean? Because if I've got my power represented by a sine wave here, and it goes on forever, where's 117 on this? Chance for you to show off. Anyone want to take a shot at it?
It's gonna be the maximum point on the sine wave?
It's actually not the maximum point. But I figured somebody was going to guess that, so thank you. So what other number would have any meaning here?
The number on the x-axis.
Actually, that would be time.
Oh,
And I'm hoping time didn't stand still when we plugged it in. Although it might seem that way sometimes.
The minimum value?
That would go down here.
Yes.
That would just be the negative of whatever that is.
Is it gonna be the average?
All right, so let's talk about average here. So I've got numbers that are, it's positive, then it's negative, then it's positive, then it's negative. If I added all these positive numbers and all those negative numbers, what would my average be?
0.
Yes, it'd be 0. So, but it is an average number, but not just a straight up average, because that would get you 0. The way that you do this is, I want to keep that up, is, well, first off, we need to make sure there are no negative numbers, so they square it. So you take all those and you square it. Then you find the average. Or the mean, otherwise known as the average, and then you take the square root of it. So this is known as, in reverse order, the RMS average, or VRMS. It's a capital V because we are dealing with a specific value. Was 117.3 volts. Was it 0.3? Okay. But how do we figure out what the amplitude is? Because this amplitude right here is the peak value or the negative of the minimum value. Well, with calculus you can show this, however, I'm just going to tell you. The peak value, the maximum value, divided by the square root of 2 is equal to the RMS value. So if you take the 117.3 multiplied times the square root of 2, we'll get the amplitude. if someone would be kind enough. This is Vmax.
You said it would be 117.3 times the square root of 2?
Yes.
About 165.89.
165.89
I got the same thing.
units? Yes. So we now have my amplitude. So right now, for the power that's coming out of our power supply here, I've got my voltage is equal to 165.89 volts times the sine of, all right, so now we have to figure out what's in the middle. Let's just assume that our phase is 0, so I'm gonna have time here. Now, what is the frequency of the US power supply? I mentioned it earlier, but also, if you've ever traveled outside this country, you would, I would assume, know it. Pardon? 120 volts is the RMS value of the voltage. That's why that 117.3 is slightly off of the 120, which is what I expect there.
60 hertz?
It is 60 hertz. That is the frequency. But we don't want the frequency, we want the angular frequency. What is the relationship between the angular frequency and the frequency?
Does that have something to do with 2 pi r?
Something to do with that,
Okay.
not the R part. All right, so as you go searching through it, omega is also, besides angular frequency, omega is also the symbol for what?
Angular speed.
Yeah, what's the formula for angular speed?
Change in angle over change in time.
Yes. So if I have something going around a circle once, what's the angle?
360 degrees, or 2 pi, or radians?
The radians is the one we want. And what's it called, the time it takes to go around once?
The period?
Yep. That's a capital T there. And so that's 2 pi times 1 over the period. What's 1 over the period?
Frequency? Frequency?
Yes. So the angular frequency is just 2 pi times the frequency. So if our frequency is 60 hertz, this is going to be 2 pi times 60. And we get $377.
370, yeah, 377.
Was it
Round
376.9 something
19, yeah.
units? No. Although you can make an argument for it, but it's misleading. It is the same units of angular as angular speed.
Radians per second.
Yeah, there we go, radians per second. So what's coming out of our power supply, 165.89 volts, sine of 376.9 radians per second. Time, plus whatever phase shift there is. Questions to here? All right, I need to erase some stuff. If anyone's still writing any of this down. I'll keep that. Keep that in there. All right. So I'm just gonna come up with some generic formula here. I have some voltage coming from an AC power supply that is some Vmax sine or cosine of omega t. Kirchhoff's rules apply, that the sum of the voltage going around the whatever gains there are, we're gonna have a loss. Except the current's constantly fluctuating, so the symbol I'm gonna use for AC current would be just a lowercase I. Please don't confuse it with I hat, because there's no hat there. I know that V minus IR has to equal 0. So V is equal to IR.